What we're about to reveal will completely change how we understand our closest celestial neighbor. China just made discoveries on the moon's dark side that have NASA scientists scrambling to rewrite textbooks. The implications are staggering, and the race for lunar dominance has never been more intense. The far side of the moon has remained hidden from human eyes for billions of years, until now. China's Chang'e missions have penetrated this cosmic mystery, uncovering secrets that challenge everything we thought we knew about lunar formation and composition. Meanwhile, SpaceX and NASA are rapidly accelerating their own lunar programs in response to these groundbreaking revelations. Today, we're diving deep into the most significant lunar discoveries of our lifetime and exploring how they're reshaping the future of space exploration. The moon's far side isn't actually dark. That's a common misconception. The term dark side refers to the hidden hemisphere that never faces Earth due to tidal locking. For centuries, this mysterious region remained completely unknown to humanity. The far side presents a dramatically different landscape compared to the familiar near side we see every night. While the near side features large, smooth plains called maria, ancient lava flows that appear as dark patches, the far side is dominated by heavily cratered highlands and rugged terrain. This stark difference puzzled scientists for decades. Why would two halves of the same celestial body look so fundamentally different? The answer lay hidden beneath the surface, waiting for the right technology to unlock its secrets. China's space program recognized this opportunity and committed to becoming the first nation to successfully land on and explore the moon's far side. The technical challenges were immense. Direct communication with Earth is impossible from the far side, requiring sophisticated relay satellites positioned at gravitationally stable points in space. On January 3, 2019, China achieved what no other nation had accomplished: a successful soft landing on the moon's far side. The Chang'e 4 mission touched down in Von Karman crater, located within the massive South Pole Aitken Basin, one of the largest impact structures in the solar system. But this was just the beginning. Chang'e 4 deployed the Yutu-2 rover, which is now operated for over 4 years, far exceeding its planned 3-month mission duration. The rover has traveled over 1,400 meters across the lunar surface, analyzing rocks, soil, and subsurface structures with unprecedented detail. The real game changer came with Chang'e 5, launched in November 2020. This mission successfully returned lunar samples to Earth for the first time since the Apollo era, bringing back 1.73 kilograms of pristine lunar material. However, Chang'e 6, launched in May 2024, specifically targeted the far side for sample return, another historic first. Chang'e 6 landed in the South Pole Aitken Basin's Apollo crater, drilling deep into the lunar surface and collecting samples that have never been exposed to Earth's contamination or the solar wind bombardment that affects near-side materials. The analysis of far-side samples has yielded discoveries that are rewriting lunar science textbooks. Here's what China found that has the scientific community buzzing. The far-side samples contain mineral compositions dramatically different from near-side materials and even the Apollo samples. Chinese researchers identified previously unknown mineral phases, including rare earth elements in concentrations never before observed in lunar samples. Most significantly, they discovered evidence of ancient volcanic activity that occurred much later than previously thought possible. Basaltic materials from the far side suggest volcanic eruptions continued for hundreds of millions of years longer than scientists believed, fundamentally altering our understanding of lunar thermal evolution. Using ground-penetrating radar above the Yutu-2 rover, Chinese scientists mapped the subsurface structure of the far side down to depths of 40 meters. What they found challenges existing models of lunar formation. The subsurface layers reveal a complex history of impact events and material deposition completely different from near-side structures. Multiple distinct layers suggest repeated bombardment events, with some materials originating from impacts that occurred billions of years ago. The water exists in multiple forms, as ice crystals mixed with regolith, as pure ice deposits in crater floors, and possibly as hydrated minerals embedded in rock formations. This discovery has massive implications for future lunar bases and deep space missions. The South Pole Aitken Basin, where both Chang'e 4 and Chang'e 6 operated, is approximately 4.2 billion years old, nearly as old as the Moon itself. Analysis of materials from this ancient impact site provides insights into the Moon's earliest history and the late heavy bombardment period. Chinese researchers discovered that the impact that created this basin penetrated deep into the lunar mantle, exposing materials that offer direct evidence of the Moon's internal composition and differentiation processes. China's lunar discoveries have triggered an unprecedented response from other space agencies and private companies. The implications extend far beyond scientific curiosity. They represent potential strategic advantages in space exploration and resource utilization. NASA has dramatically accelerated its Artemis program timeline in direct response to Chinese achievements. The agency announced plans for permanent lunar base establishment by 2030, with specific focus on the Moon's South Pole region, where water ice deposits offer the greatest accessibility. The recent Artemis 3 mission timeline has been compressed, with crew training intensified and hardware development fast-tracked. NASA Administrator Bill Nelson has publicly acknowledged that the United States is in a space race with China, emphasizing the strategic importance of lunar presence. NASA's new Lunar Gateway Station project has received increased funding, with construction scheduled to begin in orbit by 2025. This permanent outpost will serve as a staging area for extended lunar surface operations and eventual Mars missions. Elon Musk's SpaceX has positioned itself as NASA's primary partner for lunar transportation, but the company has also announced independent lunar exploration objectives. The Starship vehicle, currently in advanced testing phases, is designed specifically for large-scale lunar cargo and crew transportation. SpaceX's recent Starship test flights have demonstrated rapid progress in refining the vehicle's landing capabilities. The company plans to conduct uncrewed lunar landing demonstrations by late 2025, followed by crewed missions in 2026. The European Space Agency has announced renewed lunar exploration commitments, partnering with both NASA and developing independent capabilities. The agency's upcoming Prospector mission will specifically target far-side mineral deposits identified by Chinese missions. Japan's space agency, JAXA, has accelerated its lunar exploration timeline, with plans for sample return missions to complement Chinese discoveries. The Japanese H-3 rocket system will support these expanded lunar objectives. India, following its successful Chandrayaan-3 lunar landing, has announced ambitious plans for far-side exploration missions. The country aims to become the fourth nation to achieve far-side landing capabilities by 2027. Achievements required for far-side exploration have driven innovations that benefit multiple industries and scientific disciplines. China's successful deployment of the Qichao Relay satellite demonstrated advanced communication technologies essential for far-side operations. These satellites operate at Earth-Moon Lagrange points, maintaining stable positions that enable continuous communication between Earth and far-side missions. SpaceX's Starlink constellation technology is being adapted for interplanetary communications, with plans for lunar internet infrastructure supporting future base operations. This technology will enable high-bandwidth data transmission between Earth and lunar facilities. The extended operation of Chinese lunar rovers has advanced autonomous navigation and decision-making capabilities. These systems operate with significant communication delays, requiring sophisticated artificial intelligence for real-time problem-solving. NASA's upcoming lunar missions will incorporate these lessons, deploying more advanced autonomous systems capable of extended independent operation. These technologies have direct applications for Mars exploration and deep space missions. The preservation and analysis of far-side samples has driven advances in contamination prevention, sample handling, and analytical techniques. These improvements benefit terrestrial geology, environmental science, and materials research. New analytical instruments developed for lunar sample analysis can detect trace elements and isotopic compositions with unprecedented precision, supporting research across multiple scientific disciplines. The next decade will witness unprecedented lunar activity as multiple nations and organizations pursue far-side exploration and resource utilization. China has announced Chang'e 7 and Chang'e 8 missions scheduled for 2025 and 2027 respectively. These missions will establish the foundation for a permanent Chinese lunar research station with specific focus on far-side resource extraction and utilization. The Chinese Space Agency plans to construct a lunar base capable of supporting long-term human presence by 2030. This facility will serve as a testing ground for Mars colonization technologies and deep space exploration capabilities. The Artemis program's next phase includes establishing a permanent gateway station in lunar orbit by 2025, followed by surface-based construction beginning in 2026. SpaceX's Starship will provide heavy lift capabilities essential for large-scale construction and resource transportation. NASA's planned Farside Radio Telescope Array will take advantage of the unique radio-quiet environment to conduct unprecedented deep space observations. This project represents collaboration between multiple international partners and could revolutionize our understanding of the early universe. Private companies are developing lunar mining technologies specifically targeting far-side resources. These operations could begin commercial extraction by 2030, focusing on water ice, rare earth elements, and helium-3. Space tourism companies are planning far-side expeditions for wealthy clients, with tickets potentially available by 2028. These missions will help fund expanded exploration capabilities while generating public interest in lunar development. Far-side exploration presents unique challenges that require innovative solutions and international cooperation. Communication delays between Earth and far-side operations create operational challenges for mission control. Advanced autonomous systems and pre-programmed procedures help mitigate these limitations, but real-time human oversight remains limited. The extreme temperature variations on the lunar far side, ranging from -230°C in permanently shadowed regions to +120°C in direct sunlight, requires specialized equipment and construction techniques for permanent installations. Radiation exposure on the far side exceeds near-side levels due to reduced Earth's magnetic field protection. Long-term human presence requires advanced shielding technologies and medical countermeasures. Transporting materials and equipment to the far side requires significant energy expenditure and careful mission planning. In-situ resource utilization becomes essential for sustainable operations, driving development of lunar manufacturing capabilities. Life support systems for far-side bases must operate with minimal Earth support, requiring closed-loop systems and redundant backup capabilities. These systems are more complex and expensive than near-side equivalents. Competing national interests in lunar exploration create potential conflict over resource rights and territorial claims. International agreements similar to Antarctic Treaty Protocols may be necessary to prevent disputes. Standardization of equipment, communication protocols, and safety procedures across different national programs would improve efficiency and reduce costs, but requires unprecedented international cooperation. China's groundbreaking discoveries on the moon's far side have fundamentally changed our understanding of our nearest celestial neighbor and accelerated the global race for lunar dominance. The unique materials, water ice deposits, and geological formations found in this previously unexplored region offer unprecedented opportunities for scientific advancement and resource utilization. The response from NASA, SpaceX, and other international space agencies demonstrates the strategic importance of these discoveries. We're witnessing the beginning of a new space age, where lunar presence represents not just scientific achievement, but potential economic and strategic advantages. As we've seen, the implications extend far beyond space exploration. The technologies developed for far-side missions are advancing artificial intelligence, communications, materials science, and energy production. These innovations will benefit life on Earth while enabling our species to become truly spacefaring. The race is on, and the stakes have never been higher. China has taken the lead, but the competition is just beginning. The nation or organization that masters far-side exploration and resource utilization will shape humanity's future among the stars. What we do in the next few years will determine whether humanity's expansion into space proceeds through cooperation or competition. whether resources are shared equitably or controlled by a few powerful entities. The choices we make now will echo through generations as our species takes its next giant leap into the cosmos. The moon's far side has revealed its secrets. Now it's up to us to decide what we do with this knowledge and how we'll use it to secure humanity's future in space.